So pretend it's the final exam and you're staring at this. I don't remember exactly how much these are worth, but this would be like 10% or so of the final exam. Just this one problem here. Complete the following triangle. So what do we have to use? It might not be clear. So here's what I recommend doing. Draw a triangle. Don't make an effort to be accurate, because that might just lead you. I know this is 35 degrees, the angle A. I also know that the side A across from it is of length 10. I know one of the other angles is 20, so I'm going to put the angle 20 degrees. I'm going to put side C across from that angle, because this was angle C. I don't know angle, don't know side B. So what sort of triangle do I have? Two angles and one side. So this is actually not a law of cosines problem. This is a law of sines problem. The first thing we do is we'd say the missing angle, since we're working in degrees, it's 180 minus the two angles we have. So this is 180 minus 55, aka 125 degrees. So we come up here and I'd fill this in, 120 degrees. Great. Then we need to start finding some missing sides. The law of cosines is just not an option, because remember, the law of cosines involves all three side lengths, a squared, b squared, also c squared. So if I don't know two of them, I'm not going to be in any position to find anything here. So we're going to have to use the law of sines. Okay. Now, on your exam, of course, don't erase all of your work. It's just we don't have much space here on these slides. So let's use the law of sines. Now I can use the one that pits A and B against each other, or A and C, or B and C. The only one I don't want to do is play B and C against each other, because I don't know either of those side lengths. So let's do the version that takes A, sine A over A is equal to sine B over B. Great. So then I would have the sine of 35 degrees over 10 is equal to the sine of B over the sine of 125 degrees over length B, which just tells me that B is 10 times the sine of 125 degrees over the sine of 35 degrees. Could I compute this with a calculator? I could. Will I get extra points? No, so I'm done. 10 times the sine of 125 degrees over the sine of 35 degrees. Great. Okay, and again, I'm going to erase the work so that we have more space. You, of course, should not. Showing your work is pretty crucial to getting points on exams. And all we have to do now is find length of C. Now we can use the law of cosines here, but the law of cosines, its benefit compared to the law of sines has to do with not being ambiguous about angles. It actually doesn't save you any work when it comes to side lengths. So for side lengths, the law of sines works fine. So I'm going to say the sine of A over 10 is equal to the sine of 20 degrees, sorry, A we already knew was 35 degrees, sine of 20 degrees over the missing side length C. Now I could use the version that plays B and C against each other, where I'd say the sine of 125 degrees over 10 sine 125 degrees over the sine of 35 degrees is equal to the sine of 20 degrees over C, but I think you can tell that this denominator is just unpleasant. So since I had two options of play A and C against each other or play B and C against each other, this one works, it's just going to be a little ugly, so forget that. So going back over here, we're going to solve for C is 10 times the sine of 20 degrees over the sine of 35 degrees. And could I estimate with a calculator? I could, but I don't need to, so I just come up here and I say 10 times the sine of 20 degrees over the sine of 35 degrees. And we're done, and if I'm grading this exam, especially with the work that I can see on the sides, it's very quick for me to look at this and say, that is correct, hooray. Okay, so let's try another. So what are we given in this? We are given three sides. So draw a triangle, don't try to make it accurate. We have sides, 12, 8, and 19. Let's just be careful that we label angles appropriately. So 12 was side A, so across from it goes angle A. 8 was side B, so across from it goes angle B, and 19 was side C, so across from it goes angle C. With three sides, we want to use the law of cosines. So I need to start finding angles. It doesn't matter which one you find first, because we don't know any of them. So let's use, for example, this one. C squared equals A squared plus B squared minus 2AB times the cosine of C. This gives me cosine of c is equal to a squared plus b squared minus c squared over 2ab. So I'm going to plug those in. We're going to get 144 for a squared plus 64 for b squared minus 19 squared. So little mental trick, okay? 19 squared is 20 minus 1 squared. So if I expand that out, I get 20 squared minus 2 times 20 plus 1 squared. So that's a lot easier to do than trying to do 19 times 19. So it's 400 minus 40 plus 1, so that's 361, over 2 times a times b. A is 12, b is 8, that's 96. And how did you do 2 times 96 quickly? So 96 is 100 minus 4, so 2 times 96 is 200 minus 8, so that's 192. Okay, let me erase some stuff. Of course, you can use a calculator to do this. I just don't have one in front of me, and I'd rather not tab over to use Google to do simple arithmetic. Okay, I'm not like some sort of wizard at this. I'm not actually generally quite good at mental computation. I've just done a whole lot of it because I teach courses like this all the time. If you just practice this stuff, you'll get better at it. 144 plus 164 is 208. 208 minus 361 is 153, but it's negative. So negative 153 over 192. Both of those happen to be divisible by 3, which is not really a required step, but I'm going to go ahead and do it. So this is minus 51 over 64. Let's see, 51 is actually divisible by 3. 64 is not. So the only other factor of 51, it's 3 times 17, and 17 is definitely not a factor of 64, so this is reduced. Okay, but that's the cosine of c, which means c, I'm just going to come right to the table, is the arc cosine of negative 51 over 64. So now we have found the angle c. I'm going to erase this work, and we're going to get to work on angle b. Of course, it's going to be pretty much the same work. Once you've done it once, it doesn't change a whole lot when you do it again and again. Great. So now we're going to use the version of the law of cosines that has angle b, which is b squared equals a squared plus c squared minus 2ac times the cosine of b. We solve that for cosine of b. We'd get a squared plus c squared minus b squared over 2ac. Now I just have to compute a bunch of stuff. We get 144 plus 361 minus 64 over 2 times a times c. That involves 12 times 19. I'd really rather do 12 times 20, but 19 is just 20 minus 1. So that's 240 minus 12. That's easier. That's 228. So then I have to do, let's see. I'm actually going to do 144 minus 64 because that's easier because the 4's cancel. That just leaves behind an 80. 80 plus 361 is 441 over 228. Let's see. Does anything simplify there? Yeah, they're both divisible by 3 again. So if I cancel out a 3, we end up with a 1, carry that. We end up with a 4, carry the 2, and a 7. Divide the bottom by 3, and we end up with a 76. Let's see. I can't cancel a 2 out of each of them. I can't cancel a 3. I definitely can't cancel a 5. Whoops, sorry, I dropped something. I can cancel a 7 out of the numerator, but not the denominator. Oh, I'm pretty sure this is already reduced. So fine. That's the cosine of b. That means b is the arc cosine of that. And now notice I have 2 angles. So what's the third angle? Well, it's going to be pi minus b minus c. And since b and c are given below, that's not just like meaningless. I mean, those are numbers I can plug in there. If you prefer, you can go ahead and actually write this as pi minus the arc cosine of 147 over 76 minus the arc cosine of negative 51 over 64, but that's fine. I mean, it's commonly accepted math shorthand. You can just write these letters since those have specific values. They're not unknown, then A isn't unknown either. If you're doing calculator approximations, sure, great, you can. Not required. I want to stress you do not need a calculator to do this. Okay, I did this all by hand, and there it is, 100% correct. Okay, so there is a side-side-side triangle, which we use the law of cosines for. Let's do another. So what congruence or lack of congruence does this fall into? I'm not sure until I draw the picture. Okay, so this angle is 2 pi over 7. I'm definitely in radians mode. Across from that angle is a 14. I've also got a side length of 15. That's going to go across from angle C. And then side and angle B are what are unknown. So I've got two sides and an angle, and the angle is not in between them. This is SSA, which is a possible non-congruence, but it does suggest use the law of sines. Okay? So I'm going to use the law of sines in a way that takes the two sides I know against this angle and this unknown angle. So I'm going to say the sine of 2 pi over 7 over 14 is equal to the sine of C over 15, from which I end up with the sine of C is 15 times the sine of 2 pi over 7 over 14. Now, with the law of sines, a calculator is actually quite handy. Here's why. The question becomes, is this bigger than 1? If this is bigger than 1, I can't possibly have the sine of C being larger than 1. And it's not immediately obvious just in our heads if the 15 sine of 2 pi over 7 divided by 14 is bigger than 1. I'm quite confident it isn't, because 15 over 14, while it's bigger than 1, it's not bigger than 1 by very much. And the sine of 2 pi over 7, I don't think is so close to 1 that 15 over 14 times it would actually be bigger than 1. I think the sine of 2 pi over 7 is small enough that even when I multiply it by 15/14, there will be a possible solution there. But still, this is a case where, all right, let's use calculator. So I just have another tab open. 15 times the sine of 2 times pi over 7. And then I want to divide that by 14, and indeed, it's 0.84 to 2 decimal points. Okay, so then what are possible values of C? Remember, SSA is an ambiguous situation. So in our unit circle, I have a height of 0.84. My quadrant 1 solution is exactly going to be the arcsine of 0.84. But the other solution is going to be pi minus that. If you're in degrees, it'll be 180 degrees minus it. So as long as we're using a calculator, let me go ahead and compute. What is the arcsine? And in Google, you just type arc, A-R-C-S-I-N, arcsine of 0.84. And it immediately tells me in radians it's 0.997, which I'm actually just going to round to 2 decimal points and say this is approximately 1.00 radians. So pi minus that will be approximately 2.14 radians. So there's two possible solutions here, or are there? So how do I check? We check if the one angle we were already given will add up to be too much. Okay, so I'm going to go and say, what is 2.14 plus 2 times pi over 7? So 2.14, the bigger of these two possible angles, plus the one angle we already know of 2 pi over 7 is about 3.04. Okay, so it is not bigger than pi. So let me write that over here. I just need some more space, so I'm going to clear out space here and on the left. Okay, so what we have now is the 1 radian plus 2 pi over 7 is definitely smaller than pi. And indeed, 2.14 plus 2 pi over 7 is about 3.04. That's definitely smaller than pi, which means these are two possible solutions. If both of these possible sums are less than pi, the full angle of the triangle, if you're in degrees, you would just compare it to 180. Then we're going to have two possible solutions. So let me start a second possible column in my table. So I'm going to erase this so that I can draw by hand a new column. Okay, there are two possible solutions. Let me try to draw this reasonably well. Actually, I guess I didn't need to erase that. I have plenty of space. I could just do this. So the two possible solutions, well, some of the values have to be the same. Okay. One possible answer for C is 1 radian, but another possible answer is 2.14. So I already computed over here, 2.14 plus 2 pi over 7 is about 3.04, which just leaves 0.10 radians remaining for the missing angle, because remember, they have to add up to pi, which is approximately 3.14. If, on the other hand, I compute what is pi minus 2 pi over 7 minus the 1 radian for the other possible solution, we're going to end up with pi minus 2 times pi over 7 minus 1 gives me 1.24. Whoa, 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 stop then. 1.24. So there are two possible solutions. Okay, so now I'm going to clear all of the work off. The only thing we have to do is find the missing side length b. And I can find side lengths using the law of sines, and that's a little simpler than the law of cosines, so we'll do that. But I just have to do it twice because we actually do have two solutions in this problem. Now, when it does come time to exams, by the way these are written is it's just like 10 points, complete the following triangle. And we're not going to give away the game by saying, oh, this one here is worth 10 points, but this one's worth 20. Oh, what could that possibly mean? Nope, they're always worth 10. If you have to do two separate solutions, it just sort of means each individual entry is worth slightly less. But oh well, that's the way it goes. So let's find b. So for our left version, we're going to use the law of sines. We're going to say the sine of 1.24 radians over the unknown length b is equal to, and I can use either one I want, but I'd rather use 2 pi over 7 than 1 radian, because radians are usually multiples of pi. So I'll use a, which gives me a solution for b, which is 14 times the sine of 1.24 radians over the sine of 2 pi over 7. And I can copy that in here. 14 times the sine of 1.24 radians over the sine of 2 pi over 7. The only thing that will change in the other case is that it's not going to be 1.24 radians in the numerator. It's going to be 14 times the sine of 0.10 radians in the numerator over the sine of 2 pi over 7. Great. Two possible solutions, as sometimes happens with an SSA triangle. One more example. All right, let's fill this in to see what we're looking at. If I call this 14, then here goes the angle B. If I call this 3, then across from it goes the angle C, which I use 2 pi over 7 again. Here's my missing A and my missing A. Well, again, we've got SSA, which means let's use the law of sines to find the angle that is best suited to it. And since we have sides B and C and angle C, let's go ahead and find angle B. So the sine of B over 14 is equal to the sine of C, 2 pi over 7, over C, which is 3, from which I get the sine of B is 14 times the sine of 2 pi over 7 over 3. And now I've got some suspicions, okay? 14 over 3 is like bigger than 4. And the sine of 2 pi over 7 is probably big enough that 4 times it is larger than 1. So let's just check. I'm pulling out a calculator. 14 times the sine of 2 pi over 7 over 3 is about 3.65. It's quite large. Whoops, 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 previous slide. 3.65. So there are no solutions. The sine of B can't be bigger than 1. So no solutions. All right, so in this video, we did a bunch of problems just like you'll see on the final. You're given some values and you have to find the rest. Sometimes you'll use the law of cosines, sometimes you'll use the law of sines. There might be multiple solutions, there might be none. You just got to figure it out. So in the next video, we will finish up section 8.3 by looking at word problems that use the law of cosines.